The world is on edge as a series of outbreaks are sparking fears that a mutated strain of avian flu could eventually make COVID-19 seem like a mild illness. This trail of devastation is a grim one. Since October 2021, avian flu has caused the deaths of 15 million domestic birds, with an unprecedented 193 million more culled in a bid to contain the virus. It has been spreading rapidly, jumping from Europe and Asia to North America and then onto bird populations in South and Central America. What's particularly concerning is that avian flu is no longer confined to birds alone. The United States is now witnessing a growing list of wild mammals that have been killed by or culled due to avian influenza outbreaks. This includes grizzly bears in Nebraska and Montana, a red fox in Montana, 6 skunks and raccoons in Oregon, a Kodiak bear in Alaska, and many more. Join us as we explore the deadly impact of avian flu and what it could mean for the world's population, both human and animal. The recent outbreak of avian influenza has been spreading rapidly across the globe, raising concerns about its potential to mutate and affect humans. The first case of avian influenza in Latin America was reported in January by the World Health Organization when a young girl in Ecuador was diagnosed with the virus. This outbreak is reminiscent of the opening scenes of a pandemic movie, with the most striking event occurring last October in Galicia, Spain. The mortality rate in a mink farm of 50,000 animals rose steadily week by week, leading experts to investigate a possible link to avian influenza after another outbreak left 27 seabirds sick or dead near the coast of Coruña. Further sequencing revealed a mutation that had enabled the first-ever large-scale case of direct mammal-to-mammal transmission of bird flu. While there have been only 5 human bird flu cases reported in the last year, past cases of H5N1 avian influenza have had a mortality rate of 53% according to the WHO. The virus is already causing poultry shortages, killing large numbers of wild birds, and increasingly spilling over to mammals, leading to the crucial question: could avian influenza evolve from an ecological disaster to a full-blown pandemic? At present, scientists believe that the risk of consistent bird flu transmissions between humans is low. However, the fast-spreading avian influenza infection is becoming a contender virus that could drive the next pandemic, with a potential mortality rate that could make COVID-19 seem mild in comparison. In 2021, a particular clade of H5N1 variants, 2.3.4.4b, became the dominant strain responsible for the vast majority of new avian influenza cases across Europe, Asia, and the Middle East. The clade also made its way to Canada and the United States, and by 2022, it had reached Central and South America. The increase in mammalian infections is not surprising given the rise in outbreaks among poultry and wild birds, says Caitlin Sawatsky, a molecular virologist and animal surveillance coordinator with Tufts University. However, she describes these cases of spillover to mammals as individual incidents. According to William Schaffner, a professor of medicine at Vanderbilt University's Division of Infectious Diseases, H5N1 is primarily a gastrointestinal infection in birds that spreads through feces. To infect humans, the virus needs to attach to receptors in the lungs, but it lacks the ability to readily bond with them. This is why only poultry workers, who breathe in contaminated fecal dust, are typically infected, and why large-scale mammal-to-mammal transmission had never been observed before. In the aftermath of the H5N1 bird flu outbreaks in Galicia, Spain, researchers have been studying how the virus made the jump to minks. Isabella Mon, a researcher with Italy's Istituto Zooprofilattico Sperimentale del Venezia, believes that the minks were likely infected by contact with wild birds. Once in the dense population of mammalian hosts, the virus developed a mutation in a gene called PB2. This mutation is known to increase the activity of an enzyme involved in viral replication in mammalian cells. While it's too early to know how much this contributed to the virus jump to minks, the same mutation was also found in the strain of H1N1 swine flu that caused the 2009 pandemic, killing between 123,000 and 203,000 people worldwide. The PB2 mutation is concerning as it shows the virus is attempting to adapt to the mammalian population. Caitlin Sawatsky, a molecular virologist and animal surveillance coordinator with Tufts University, believes that the mink case is not necessarily an example of sustained transmission, as no workers were infected and the minks were culled. However, the PB2 mutation was concerning, and the viral genome was closely monitored. Sawatsky is more concerned about the mass mortality of harbor seals off the U.S. coast of Maine last year and the more recent deaths of 2,500 seals off the coast of Dagestan, Russia. Seals don't consume or get exposed to birds in quantities that would explain their high infection rates. This suggests that the seals may have an as-yet unidentified alternative route of infection in a wild population that cannot be as easily monitored or culled. Developing an entirely new vaccine would likely take 6 to 7 months, said Schaffner. Existing stockpiles of antivirals, he said, would likely be consumed quickly. Thus, if the bird flu sweeping the world does lead to a pandemic among humans, it would probably fall on lockdown procedures to buy time for a vaccine. COVID has told us about the effects of behavioral interventions, said Schaffner. During lockdowns, while we were social distancing and all wearing masks, we had a season with almost no influenza. In the wake of COVID-19, people are practiced at distancing procedures. Granted, another lockdown might be a hard sell to a weary public. Nevertheless, given the high mortality of historical H5N1 cases, Schaffner believes that once casualties start rising, people would likely toe the line, slowing the spread of a potential avian influenza outbreak. To be sure, there is only a slight risk of avian influenza targeting humans at the moment, but that comfort belies 3 concerning certainties. There will be an influenza emergency at some point. There are simply too many types of influenza, which mutate easily, and for which humans have limited resistance. Bird flu is a growing contender for the pandemic prize, threatening a mortality rate that far eclipses that of COVID-19. And in some ways, H5N1 is already a pandemic. It is a pandemic on the beaches of Peru, where more than 10,000 pelicans have washed ashore in recent months. It is a pandemic in the empty nests of seabird colonies the world over. It is a pandemic for those who rely on both the money and food provided by poultry production, who had to cull millions of animals in the past 15 months. Nutritionally, economically, and ecologically, H5N1 is already a crisis. And despite the current low risks, the high-stakes threat of a bird flu pandemic among humans has the world at attention. As we conclude this podcast, we are left with some important questions to ponder. How can we better prepare for future pandemics caused by zoonotic diseases? What measures can be taken to prevent the spread of avian influenza from poultry to humans and other animals? And perhaps most challenging of all, how can we balance the need for economic development and human progress with the protection of biodiversity and the prevention of zoonotic diseases?